The lava lamp. Bubbles that float and sink in a liquid. Psychedelic lighting, like something straight out of the 60s. Still, the lava lamp is pretty fascinating. Not because it's so mesmerizing, but because it provides a concrete illustration of an essential law of physics, the Archimedes principle. This lamp is a real-life physics laboratory, varying the density of bubbles and in turn varying their buoyancy. In fact, the lava lamp is Archimedes' principle in action. Okay, now how does it work? The idea behind the lava lamp is simple and extremely clever. The trick is to constantly change the density of the, lava. When the lava is less dense than the liquid, it floats and rises to the surface. When it's more dense, it sinks to the bottom. So how is the density varied? The lamp uses heat to change the volume of the lava. The best way to understand it is to take it apart. The lava is essentially a mixture of colouring and wax. The translucent liquid is mainly water. Two liquids with almost the exact same density, but the wax is slightly more dense. That means for the same volumes of water and wax, the wax is slightly heavier. Of course, that also means the wax should always be at the bottom of the lamp, but that's not what happens. Why? At the bottom of the lamp, a bulb lights up the show and heats up the wax. Heat is key to varying its density. A twisted metal wire transmits the heat of the bulb to the wax. The molecules of wax become agitated, taking up more and more room. The result, the wax expands. The volume of the wax increases, even though its weight stays exactly the same. The wax is now less dense. It's now less dense than the water and no longer sinks. Instead, it rises. It's the Archimedes principle in action. When an object, like a wax bubble, is immersed in water, it's pushed upward with a buoyant force equal to the weight of the water being displaced. Water is pushing on all sides of the object, but the strongest push is upward because the water pressure increases as we move deeper. The larger the volume of an object, the more water it displaces. The more water it displaces, the stronger the buoyant force pushing it upward. If the object is heavier than the water it displaces, it sinks. If the object is lighter than the water it displaces, it starts to float. That's the principle behind the lava lamp. Cool wax is heavier than the water it displaces, so it sinks. When the wax is heated, its volume increases, displacing more water and increasing buoyant force. The weight of the water displaced by the heated wax bubble is now greater than the weight of the bubble, so the bubble is forced up and begins to float. As it rises through the lamp, the wax gets further from the bulb and cools. Now the opposite happens. Its volume decreases, it displaces less water, and the buoyant force loses strength. The wax is now heavier than the water it's displacing and begins to sink. It goes right to the bottom, where the bulb heats it up again, and the whole cycle starts over. By using heat to vary the volume of the wax, the lamp makes it less dense than the water and then more dense than the water. The variations are tiny, but they're still enough to make the wax bubbles alternatively float and then sink. The lava lamp, a never-ending show, starring the Archimedes principle.